The ancestor of the modern trumpet was a straight horn that could emit just a few notes. By the 15th century, they learned how to bend the horn, increasing the length of the instrument and the series of notes it produced. The invention of the valve in the mid-1800s finally allowed the trumpet to be played in any key. A trumpet is made up of 1.5 meters of tubing. 3 valves allow air to flow through additional tubing to alter the trumpet's pitch. Trumpets are made from sheets of metal, most often brass. This factory combines different thicknesses in a single instrument to attain a particular sound. Workers first lay a template on a brass sheet and trace it out. They then cut along the score line with electric shears. This piece will become the trumpet's bell. A manually operated press forms a perfect fold down the middle. Then they notch the edges. Then they close up the bell by hammering the notched pieces into the opposite edge. They use a rawhide mallet because anything harder would damage the brass. They melt a brass alloy along the joint. It solidifies into a metal seam that bonds the edges permanently. They slip the bell over a cone-shaped mandrel and hammer the brass until it too is cone-shaped. Then the bell goes onto another mandrel mounted on a lathe. They push the brass against the mandrel to finalize the shape. Then they file the metal smooth. Now for the bell's rim, called the bead. A brass rod with a notch at the end catches the edge of the bell and rolls it back into a rim. They use what's called a concave roller to round the rim's jagged edge. Then they slide a brass alloy wire into the rim pocket. This makes the bell stronger and adds weight to the edge of the flare to project sound better. They roll the rim over even more to enclose the wire. Now they heat the rim and apply acid flux to clean the surface for soldering. Lead or silver solder ensures the wire won't rattle when the bell vibrates. After wiping off the excess flux, they put the bell back on the lathe and scrape off the excess solder. Using an abrasive sponge, they smooth away any scratches left by the scraper. Then they remove any solder bits trapped in the rim. Now they'll fill the entire bell with a soap and water solution, then freeze it at -49 degrees Celsius. When the water has frozen, they place the bell in a bending block. The ice provides counter-pressure, preventing the brass from buckling inward. The ice itself doesn't shatter under the pressure because the soap in the water makes it pliable. After checking the angle of the bend with a gauge, they let the bell defrost. In the mounting department, workers assemble smaller components made of brass and nickel, valve casings, the sliding tubes to which they connect, the slide for tuning the trumpet, and the pipe that holds the mouthpiece. Then they solder on the bell. They lubricate 3 pistons and install 1 in each valve casing. These slides have to fit loosely enough to move freely, but tightly enough to prevent air leaks. 1 slide has a finger ring for holding the trumpet. After polishing and lacquering the brass, they test the trumpet for sound quality. This is one company that likes to blow its own horn.
never slow up, no I don't take shit, I got no love